Greetings, chemistry students. The goal of this recording is to give you some vicarious practice and some introduction to some very key core information resources in chemistry, sources that you will use from now on in the chemistry classes that you take at Grinnell. Plus, if you go on in chemistry, graduate school, if someday you end up as a chemistry professor at Grinnell 20 years from now, you will use these resources. So wherever you go, they will probably be in the format that I will talk about here in the next few minutes. I want to encourage you to ask questions, and I know you can't do it in a recording, but please, if you have questions about using these resources, finding information, talk to your professor, talk to your class mentor. You can always talk to me. I always have your back. I will show you in a couple of minutes a good way to get a hold of me. As we're all off campus at this time, you'll be communicating by email, but please don't hesitate to do that. So I'm going to share my screen and let's get into it. Here's the Grinnell College homepage, which you're familiar with. Let's go to the library, which you are familiar with too. I strongly encourage you to use the subject and course guides as your jumping off spot as you're searching for information, not just in chemistry, but in other areas as well. And there are many, many guides. Hopefully you've used some of these in the past. Hopefully you may have even used the chemistry guide, but I strongly encourage it both because it's a one-stop place for finding links to these important chemistry resources. But second, and very importantly, during this time when we're all off campus, or most of us are off campus, it provides proxied links. In other words, links, you'll go through our proxy server, which will authenticate you as a Grinnell College student and will give you direct access to these resources. On this page is a great way to get in touch with me. This button, email me. You can also use request a library lab. If you wanted to set up a specific appointment, say, Kevin, let's meet Friday at 2, this would be a way to do it. It will also ask you, if you go this link, to fill out some other information that would help me prep for our meeting. You don't have to use this link if you don't want to. You can just use this as well. But either way, please contact me. Just to kind of step through this guide quickly, just show you some of the things that are here if you haven't seen it before, which is fine. Note that critical source evaluation, where you think critically about not only the information itself, but from where it came from, is the most important thing you do in any search for information. Please do not think that just because you're using academic information that it does not have problems of misinformation and disinformation like you see elsewhere. It does. There are more kind of unique problems. And if you're interested in this and want to see one of the big problems in academic communication right now, read this article from The Guardian on predatory publishers. Note, as we go through here, we've created a bunch of videos for you that you might want to take a look at, which kind of talk about evaluating information and how to get the most out of primary literature. The define step provides kind of what are called secondary sources, or in other words, not actual accounts of research, but more overview pieces. And at this step include our many, many sources in chemistry that provide like physical property data and things like that. So this is an important step. And as we look at this, I want to show you two things. One is that many helpful resources in chemistry are in print form and will always be in print form. They're kind of older books that really have no commercial value now. So there's no value in digitizing them from a publisher. So if we were on campus right now and you were in the science library, I could show you a whole raft of books which can be very useful. Their use is often because they deal with a more specific subset of information rather than millions and millions of pieces. So for example, when we search chemical abstracts in a little bit using SciFinder, we'll be looking at a database that has information about 50 million plus chemical substances, millions and millions of reactions. Sometimes, like if you're looking for basic information about a well-known reaction, a book that covers 100 important reactions in chemistry may be a lot easier to use and find information. Some of those books are starting to become available electronically, and we've listed some of them here on the chemistry subject guide. But just remember, there are many of these sources that will always be just in print form. But let me particularly aim you at this resource, Organic Syntheses. And I'm going to click the link and show this page. So one of the challenges in chemistry, particularly when you're looking for information about synthesizing or preparing a chemical compound, is you'll find articles, maybe many articles about how to do it or how somebody did it. But when you go into the lab and use their recipe, it doesn't work for you. And the natural reaction to that when it doesn't work for you is to retry it, but then it doesn't work again. And you begin to think that something's wrong with you. And in fact, nothing's wrong with you. What's wrong or what's changed is that the researcher or researchers synthesized this chemical compound at a laboratory somewhere else with different conditions than the laboratory you're working in. They could be very subtle, but enough so that their method does not work for you. Organic Syntheses is a publication of reliable methods for the preparation of organic compounds. That's a mouthful, but basically what it means is these people, and this has been published since 1921, these people verify methods of synthesis so that when you find a method of synthesis of a chemical compound in this resource, it's reliable. It will work in different places. So again, if you're looking to synthesize a compound, I would go here first. And you could search this by text, by citation. You can draw a picture of your compound. You can do a variety of things. I would search to see if you can find one. Now, this resource covers thousands and thousands of compounds, but nowhere near the 50 million plus that are in Chemical Abstracts and SciFinder. So odds are you may not find what you're looking for in here for your particular compound, but if you do, it saved you a whole lot of time because you've found a reliable method to produce that chemical. So looking for synthesis information, go here first. It'll take you 5 to 10 minutes to see if you're finding a method for your particular compound. If you don't, you haven't spent much time doing this. So go here first for synthesis of organic compounds. All right, let's go to the Identify tab. And it's on this page where you're actually going to be searching and finding what's called primary literature. So actual accounts of research studies written by the researchers themselves. And the one you want to go to here is this one called Chemical Abstracts. And then right after it, you see this thing called SciFinder N. So Chemical Abstracts is the most comprehensive database in chemistry for finding published research literature in all areas of chemistry, in all languages, back to the 1800s. If you're looking for a way to synthesize, if you're looking for something else, this is the place to go. Don't go anywhere else. Start right there. Now, I just said for synthesis, go to Organic Synthesis. Yes, do that. But once you've gone to Organic Syntheses, if you're doing synthesis, you go straight here, not any of these sources above. Let me tell you a little bit about SciFinder and Chemical Abstracts. A lot of times people conflate the two. Chemical Abstracts is the database, which has information about the 50 plus million substances identified in the chemical literature since the 1800s, the tens of millions of reactions, et cetera, millions and millions of records describing articles and book chapters and web preprints and dissertations, etc. SciFinder is a software tool to search this efficiently. A lot of times people will conflate the two and say, that I'm searching SciFinder. Yes, you're searching SciFinder, but actually you're searching SciFinder to actually get into this database. In order to use SciFinder, you need to register. And you need to register individually. So it's not a database you can just click and get into. You click it, and then you have to log in, and you have to register individually. And to do it, you click this link, and you would then log into your account. And you would go through the Duo process, which I'm doing right now. And I'm going to do that. And it's going to take you to this page. We're going to register you as a new user. You're going to say next. You have to accept this. And then this is the page you fill out. Just be sure to fill in all the information. Select a username and password. It doesn't have to be the one you use at the college. In fact, I would suggest you pick a different username and password. Click register. You will receive very shortly an email message from CAS. It's the company behind SciFinder. Within that email will be a verification link. Click that, and then you'll be registered, and you'll be able to use SciFinder 24/7 on campus or off campus. All right, let's get into SciFinder. Let's get into SciFinder and searching chemical abstracts. Again, you want this link that says Chemical Abstracts SciFinder N. It is the best source indeed. And you're here going to put in your username and password. And let me just type it in. And this is mine. Okay, this is the initial screen of SciFinder. And again, you're searching both the Chemical Abstracts database and the Medline database by default. So I'm going to show you two methods I'm actually going to show you three methods of searching this database. And if you are doing something revolving around a particular substance, and you have pretty specific information about that substance, I would suggest you use method one. So here's method one. Click Substances. Put in the name of the substance you're interested in. So let's say for example purposes that we are interested in the substance hydrogen peroxide, and we're looking for a way to synthesize that, to prepare it. I'm going to click to search. And what I've done here is go into what's called the registry file. And the registry file is this place where you'll find in-depth information about the 50 million plus chemical substances identified in the literature of chemistry since the 1800s. And here's hydrogen peroxide. And here's its H2O2. And there's this strange number up here. Let me click that and just kind of explain what this number is. It's called a registry number. And you may have seen this already when you've read an article in a journal or looked in like Lang's Handbook of Chemistry, and you'll see a number like this. If you are working on a particular substance and you find its number, be sure to write it down. So why do they use odd-looking numbers? It's because down here in the record, other names and identifiers, it's because chemical substances often are known by a lot of different common names. So hydrogen peroxide, for instance, is known by at least 80 names. So Crest white strips, the stuff you put in your teeth to make them nice and shiny and white, is hydrogen peroxide. Oxidol, the laundry detergent to make it bright and shiny, is hydrogen peroxide, and so on and so forth. There's no way you could do a comprehensive search on this substance if you had to search on 80 different names. So instead of searching on 80 different names, you identify it by an individual unique number. And this number is both the most focused way to search about hydrogen peroxide and also the most expansive way. And I'll show you an example of this here in a couple of minutes. This record has lots of information about hydrogen peroxide, a lot of physical property data. So for instance, experimental properties in various categories. Thermal, for instance, let's say you're dealing with boiling point or melting point. They give you some values which have been determined through research in the past, and then they'll send you to the actual article or whatever it was, publication, where that information was reported. So you get a value and they take you back to the place where it was first reported so you can make your own decisions about the value of this information. There's all kinds of things here, spectra, on and on and on. A ton of information. But let's go back to our example here where we're interested in finding a way to synthesize H2O2. I'm going to click this thing up here called References. And it's going to put me into this list of 327,905 references, or in other words, articles, patents, reviews, etc., all about hydrogen peroxide, or where hydrogen peroxide figures as a major part of the content of that publication. I'm going to break this down by a couple of these options on the left. So I could go, for instance, under substance role. See where I am? I'm going to click View All. And notice as I go down here, I find preparation, 9,713. So preparation in chemistry means synthesis. So if I want to find out how to make hydrogen peroxide, there are articles in this category. So I'm going to click that. And it's going to initiate a search. And here are those 9,713. So let's break it down some more. Language. Well, there's things in many languages here. And frankly, the only ones in English are going to do me any good because I can't read any of these. So I'm just going to click English and apply. But you could click all the languages that you can read. So now we're 4,458. One more category you could do by year, publication year as well. But I'm going to go down to concept. What does that mean? Concepts are kind of the subject headings of this database. So let's say, as an example, that I'm interested in an ecological or a green way to synthesize hydrogen peroxide. So I would go under concept and I would search for something dealing with green chemistry. And there I am, 40 in green chemistry technology 2. So I'm looking for a green method to synthesize hydrogen peroxide. And this is the way I break it down. I apply. And I'm down to 41. Note that these 41 are sorted by relevance by default. I like to do relevance. And you could still break them down from here, but these are all records for articles. So as an example, number 2, an article by Biase, Continuous H2O2 Direct Synthesis over Palladium Gold Catalyst. And I'm going to click this to bring up the record itself. This comes from Chemical Engineering Journal from 2011. It's in English. Here's the title of the article, the authors, something about what's the article about, the abstract, keywords. And then if I go under concepts, my green chemistry appears there. And here's the substances. These are the substances that play a major role in this article. H2O2, palladium gold. Now, if I was in here and I looked at this article and I said, this looks good. I need the full text. Notice there's a button here saying full text. I click that. And there's some various options here, but the one I want is this one called DOI, or Digital Object Identifier. So if you click this, you get to the same place I'm going to go to. But if you want to cut back a click DOI, and it's going to see, do we have access to this article? And we do. It's gone right to the page. I can click here and I can download a PDF of the article. So let's say I look at this article and say, this is right on what I want. How do I find more like this article? Well, I can do a couple of ways. One is under citations here. This is the bibliography of this article. So 35 items that these Biasi and the other authors use to do their research. But these are all older than the Biasi article because they're in the bibliography. But some of these might be relevant if I'm looking for additional things on this subject. So I'm going to look in here to find additional items. I'm also going to look under cited by. And these are 38 items that cite the Biasi article. In other words, the Biasi article is in their bibliography. And these items, because they cite Biasi, are more recent. So going through the bibliography goes back in time. Going through cited by goes forward in time. The bibliography and cited by are very important ways in chemistry to find related relevant material. So this is method one. When you're, let me do one other thing. Let's say I go here and I say, well, I'm interested in this synthesis of hydrogen peroxide using these palladium gold catalysts. I would like to find other items that specifically talk about the palladium gold catalyst. So I'm going to go back to my list of 41 and I'm going to go down my list of filters, and at the very bottom it says search within results, and I'm going to put gold or palladium. I'd already typed it in. Click find, and I've broken down my list of 41 to 13. There's the Biasi article, and there's others. Direct synthesis, hydrogen peroxide over gold, palladium catalyst, so on and so forth. So that's method one. If you're searching on a particular substance and something to do with that substance, name at least, or a formula, or a registry number, method number one using the substances option is a good way to go. So let's go to method number two. I'm going to go under references this time. And let's say here let's in fact use the information that I discovered through method number one, just to give you an example. I'm going to put in the registry number for hydrogen peroxide. So instead of typing hydrogen peroxide, this number stands for it. And again, it's the most focused and most comprehensive way to search. So I'm interested in hydrogen peroxide. I'm interested in preparation, which is the term in chemistry that stands for synthesizing. And I'm interested in a green method of doing it. So hydrogen peroxide, how to prepare it, how to synthesize it, and a green method of doing it. Click this. It's being a little slow here. Here we go. 1,238, bigger number. Let me use the filters again to knock this down. I'm going to say language. I can do that again. I'll go with English. I'm going to go under concept again, like I did the last time. I'm going to view all. I'm going to do the search again, green, search, green chemistry technology, like I did last time, apply. 499. And then again, like I did last time, I'm going to add the gold or palladium search. And I'm down to 36. So method two is not quite as direct as method one, but if you have kind of less information your search is a little more vague to start with, this is the way to do it. Let me just show you an example. When I do it this way, obviously not all of these are about preparation or synthesis of hydrogen peroxide, but they have all these terms in. Hydrogen peroxide figures as part of the subject content. So for instance, it's not till number, I believe number 12 that the Biasi article appears. But all those 13 articles we found before are within these 36. But let me show you one more, and just for practice sake, here's direct production of H2O2, palladium catalyst, Journal of Supercritical Fluids, 2012. Just for practice again, how do I get the full text? Full text, DOI. There it is. Download the PDF. If you ever search for full text and you can't get it, in other words, you click on DOI or click get full text and it essentially says, we don't have immediate access to this. What I tell students is 3 clicks. 3 clicks. If you don't get the full text, the full content within 3 clicks, just copy and paste the bibliographic information here, title, this kind of stuff. Copy and paste this, put it in an email, send it to me, and we will get it for you. So 3 clicks, no full text. Don't search for it anymore. Don't spend time doing that. Copy and paste the basic information, journal, pages, date, all this stuff. Send it to me in an email. We'll get it for you. If we can't get it for you in anywhere from a few minutes to a few hours, you will always receive an email and we will tell you, this is what you need to do to get it, and it will take approximately this long. So give you something to plan on. So don't spend a lot of time looking for things. If you go through the full text option, click the links, can't get the full text in 3 clicks, send me this information, move on to the next one. All right, let's go back to SciFinder and let me show you a third way that you can search this. We're going to return to results, and then we're going to return to home. And the third way involves drawing a picture, and you can use this with either substances or references or reactions for that matter. But let me give you an example. Let's say I'm interested in the chemical compound ozone, and I picked this because it's easy to draw. Obviously, you'd be drawing a more sophisticated picture, but here's ozone, O3. A lot of times it's easier to draw a picture of what you're looking for with the bonds and various things rather than to try to describe it in words. So I draw that, I click OK. There's my picture, I can search it. And I get 141,000, it's a lot of them for ozone. I click this, and if I go under the substances part of this article, there it is. There's my substance. That's what's being searched when I search that picture. So let's go back to our results, back to home. And you can search by a picture, but you can combine that with words. So let's say we did something like ozone. But we want to combine it with like climate change and something to do with food, like food supply. So how does ozone interact with climate change to affect like food supply? So I have words, I have a picture. I search. And I get things like this. How is ozone pollution reducing our food supply? I click this. And in the concepts, I have food. In the subject headings, I have food supply, climate change. That's why it came up. In the substances, I have ozone. That's why this particular article came up in the search. So three methods. Method 1, through searching through substances to start. Method 2, searching through references. Method 3, searching using drawings, pictures. This is kind of a unique feature of Chemical Abstracts and SciFinder. You will find, I think, that as you do more and more searching in this database, that more and more of your searches will involve drawing a picture, because it is easier times if you have a particular substance and you can't quite come up with a name, or a name that's coming up with any hits to it, and your molecular formula could be used for many substances. Drawing a picture and searching against a database may be the quickest way to get at what you want. All right, I will stop there. Good luck on this, chemistry students. If you have any questions, any problems, if you're having problems registering for SciFinder, if you're having problems using the database, finding what you need, any of those things, again, contact your professor, your class mentor, but you can always contact me. Use that question button on the chemistry subject guide. Use the chemistry subject guide as the base from when you start your search. All right, thank you very much. Good luck. Take care. And thank you. I'll see you.